So for the majority of projects that I work on at work, we typically use AWS for a lot of different things. And more specifically, AWS Lambda is what we typically use for our APIs, if we have like a serverless function that we need to run. So I would say I have a decent amount of experience using Lambda. And I want to share with you one of the hardest bugs that me and my team had to figure out when it came to Lambda. So even if you don't use AWS Lambda, I think there's a lot of good information that you might get from this video, just about debugging in general and how to approach solving a problem. So let's just go ahead and jump into it. So in the system that I work on at work, we have a lot of users such as judges and attorneys who have to basically pass around PDFs and have those things signed. So generating PDFs, signing PDFs, manipulating PDFs is something that we do a lot in our system. So the way we do in our system is we have a lambda or different lambdas that's invoked, and that lambda is including a third-party library to basically generate these PDFs. Okay, so that thing will generate a PDF, and then we will basically store that PDF in S3. So if we zoom in and just look at the key pieces, like this is basically it in Node.js. We use Node.js as a runtime when we do the serverless computation. So in order for us to generate PDFs, we brought in a third-party library called Puppeteer, which basically uses Chrome to generate these PDFs. You can also do like screenshots, you can do other like web crawling stuff with it. But there's limits. There's limits to Lambda, and one of the limits is you have a 250 megabyte limit for what you can run on Lambda. And so depending on the total size of your execution code, this Puppeteer package, Chromium, whatever binaries you need, and then if you have third-party libraries that you also need, you can easily get over 250 megabytes with this package alone because it's pretty big. So there's another third-party library called Spartacus Chromium, which was built basically to work on Lambda. Now what this does is it basically takes that giant binary of Puppeteer and it finds a way to prune it down to make it small enough to live on a Lambda. And this library works pretty good, but although it's like maintained by like one person, so we've had some issues with it. So basically what happens is we have a Lambda and then we use a Lambda layer over here, which has that Puppeteer Chromium / whatever package. So I'll go ahead and just draw a line here and this will be our Puppeteer layer. And so what a layer is basically just like some additional dependencies that you can add to a directory or something. And when this Lambda spins up, it's going to take everything in the layer and basically have access to it inside of your Lambda. Now, the reason you might want to use a layer is if you have multiple Lambdas, all needing to have access to PDF generation, you can easily just use this layer inside of whatever Lambda that you deploy, and you'll have access to do PDF generation. So that's a high-level overview of what we're trying to do. So let's talk a little bit about what was the bug. What happened in production that was actually really hard to figure out and debug? So how we work in our team is we have a test environment, we have a staging environment, and then we have a prod environment. Before we can get anything promoted up these environments, we have a whole suite of end-to-end tests and integration tests that basically run over the code. So like we'll have some code, maybe we'll do some package updates, maybe we'll do some code changes, and we will deploy that through GitHub Actions and a CI/CD pipeline to get that deployed out to one of our environments. Again, we have a bunch of smoke tests and end-to-end tests and integration tests that verify, is the thing that we're deploying, does it actually work the way we think it does? So in regards to this bug, we made some code changes. Sometimes you have a lot of code changes that need to go out, and we got that deployed to test. All the automated tests that we wrote seem to work fine. We also have people on our team who use the test environment. So again, the reason I mentioned like what we do at work is because PDF generation is one of the core things we do on our project. Like everything has to generate PDFs. Everything has to sign PDFs. Every process basically touches a PDF in some way. So we'll have like a QA user, and then we also have dev users, right? And all of us are like playing around with tests, making sure everything's good. And we didn't notice any bugs. Everything seemed fine. All the PDFs were generating fine after this little code update. So we're like, you know what? Let's just go ahead and promote the staging. So we got the code, deployed at the staging. Again, you might have one user, like the product owner or someone, do like a sprint demo using that environment or something. And again, no issues. Everything is working fine. So then the issue came is when we deployed to production. So in production, obviously you have more users all trying to generate PDFs, sign PDFs, send PDFs around. And this is when issues started to happen. It turns out whatever code change that we pushed to prod, for some reason, about one in every couple hundred or couple thousand of Lambda executions, all the PDFs would start failing. So someone would call an endpoint to make a PDF. It worked fine. So I think we deployed on like a Monday or something, and the first time the error showed up in our CloudWatch logs was on a Tuesday or a Wednesday or something. So because it took so long for this bug to show up in production, we honestly didn't think it was related to the production changes we did, and we thought it might have been something else. And it's very hard to pinpoint, like, okay, what was the change that is causing this? So typically when there's a bug in your production system, the first thing you want to do is try to reproduce it locally, which is great. But the issue is that this bug was very specific to when you deploy to AWS. You can't reproduce this bug locally because when we're running locally, we don't use this Spartacus Chromium package. We just use Puppeteer directly because we have enough space to run it. Secondly, I think Spartacus Chromium is built for a particular runtime in Lambda. So I think if people are using their Macs, this thing might have been built for whatever Unix operating system that AWS uses. I forget off the top of my head, but typically in order to get binaries working on Lambda, you have to basically pull in a Docker container and you have to build it for a particular operating system for it to work. So locally, we're using Macs, and this is going to use a different binary, and we also didn't have to use this package. So the first thing we did is we tried to reproduce this locally because we're like, you know what, we don't know what's causing PDFs to fail, so we wrote like some scripts that just basically hit our endpoints locally 1,000 times to 5,000 times in a row, and we noticed that we got absolutely no issues. The issue comes is when you deploy it to AWS, and of course it's using a completely different package. So that's kind of the first thing you're going to learn from this video is if you can't run everything in production the same way you're running it locally, it's probably better to figure out a way to do that. And I do think using containers and Docker is probably still the best way to make sure that your production environment emulates your local environment. But I think we ran into this bug before Lambda even gave us access to running Docker images or containers inside of Lambda, so we couldn't really do that, right? Now, second thing I want to talk about Lambda is when you write a Lambda function, typically you have like a handler, right? You have a main handler, and this thing is going to get invoked every single time a request comes into the Lambda. But there's two important things you want to talk about when it comes to Lambdas. There's cold starts and there's hot starts or warm starts or whatever. So if you've had zero traffic, no one's ever hit your API endpoint, or you're deploying a brand new version of your Lambda, the first time you invoke that Lambda, it's going to do a cold start, which means it has to kind of initialize all of your node modules and import them and get everything set up. And that takes some time, right? So it's kind of slow to do a cold start. And additionally, with the Spartacus package, it had to load in some underlying binaries, which took some more time as well. So on the first request, load in binaries. And typically with a Lambda, you have the ability to cache things. Okay, so anything you put outside of this main function, this could potentially be cached. So now when the second person invokes this Lambda, it's a warm start, which means all this stuff is already initialized. Okay, so like Spartacus has already been loaded in, the binary is already there. And the reason this is an issue is because for some reason, after you invoked the Lambda multiple times, it would put the entire Lambda into a broken state. So one of these runs, for some reason, would modify some type of underlying cached resource that was used in the Spartacus package. And then any additional request to the Lambda would just throw errors because it could no longer generate PDFs because the underlying third-party library we're using, something it was doing was just breaking, right? And the only way to get around this is you'd have to hope that it would call a new Lambda with a cold start and kind of initialize this thing with some fresh code. And this is kind of why we didn't see any errors show up until like a couple days after, is because it took a lot of executions of this Lambda once it's warm until it actually started throwing errors. And so if you have traffic hitting your API, it's going to spin up a bunch of different Lambdas and keep them warm for a little bit. And then it's going to tear them down after some time, right? And so if you don't get enough traffic to basically hit the same Lambda over and over and over again, you can't reproduce this issue. So what was the actual issue that caused this? Obviously, it was just a version update. When someone was doing their dependency updates, typically every week we have one developer go through and try to update every single package in our package.json. Okay, these things need to be kept up to date. If you don't, it becomes harder and harder and harder as your system grows to update these things. So our team, we like to dedicate one person every week to just go through, update all the dependencies of Terraform, update dependencies of whatever Docker images that we might be using, update dependencies for package JSONs, just so that we're on the latest version of things. And then we run, security checks on those updates, and we actually run the UI locally. We run the UI in CI/CD. We make sure all those version updates don't break anything, and then we'll get that deployed out. But unfortunately, without our knowledge, when you update this package to a particular version, it just starts throwing that weird issue. So because of this weird caching issue, and because the bug didn't show up for multiple days after, and because we looked through all the PDF generation code and nothing changed, and then we also ran this stuff locally, and we also tested on test and staging, and nothing was ever failing. This was a very hard bug to debug. In retrospect, we should have looked at the package JSON and saw that someone bumped a version, like a minor version of this package up, and that actually caused the issue. So there's a couple of main takeaways from this video. Always check your package updates if you start getting bugs in production. Now, sometimes it's easier said than done, because if you update your packages and there's 30 different libraries that changed, it becomes a little bit more difficult to pinpoint, okay, what exactly is breaking this? Because I think we have like 3 different Puppeteer packages. It gets complex. In a bigger system, it all gets a little bit complex. But that's my first tip, is just look at the package JSON. Did anything update? And you also need to realize that when you have this caret here, that means that any minor version can update, right? So if you want to play it safe, you really should be pinning these things down. Right? After you get everything set up, pin them down so that every time you deploy your code, it's using the exact same version. Because although a patch version number update shouldn't break, you never know, right? The second thing I would really recommend when it comes to Lambda is that if you're dealing with third-party binaries, I would probably just use a container and just have your code live in that container with whatever binaries that you need. For example, if you're trying to do PDF generation, make a Docker image, put your code on there, put whatever binaries you need, and then deploy that to Lambda directly. This is like a newer thing they added over the past year or two, is that you can actually deploy containers to Lambda. And this would have made our life so much easier when debugging this, because we can run the exact same code locally. I could have spun up a container, I could have invoked it with 5,000 requests to generate PDFs, and we might have seen some of these issues happen. But what we were seeing in production, there's really no way to replicate that error. So I would say the closer you can get a local environment running to production, the easier it's going to be to debug. But honestly, sometimes you can't. Sometimes, depending on where you're deploying your stuff, it's just not possible. You might have tons of different services that need to run. You can't emulate the real DynamoDB locally. You have to use some type of random mock. You can't emulate the real OpenSearch locally. You have to use some type of like Elasticsearch binary. Those are the main takeaways from this bug. Hope you guys learned something new about debugging or just Lambda in general. I think I covered a decent amount of topics here. So if you enjoyed watching this video, be sure to give me a thumbs up and subscribe. Like always, I have a Discord channel you guys are welcome to join if you want to find a place to kind of hang out or talk to other developers. Other than that, have a good day and happy coding.